Greetings, you sexy bastards. Welcome to Principles of Programming Languages, where I, Dante Alsonio, teach you the underlying principles of code that apply to every language so that you can be a more versatile and adaptable programmer. Once you understand the underlying ideas that you're trying to communicate, the actual words or code that you use to communicate those ideas start to come to you effortlessly. Today in chapter 1, we're going to look at variables and how we use them to represent information in a way that the computer understands, as well as the underlying principles of variable declaration that goes into every programming language. Remember, every coding language is just a different way to communicate the same underlying ideas. They're just using different words to do it. So let's get to it. I'm going to start us over here on my iPad. That way we can go through a couple of concepts and then we'll actually look at the code, and then we'll jump back over to ChatGPT where we can look at how these concepts apply not only to the code that I'm going to show you, but to any coding language. So, for starters, let's talk about what it means to communicate ideas to computers. Ultimately, all that coding is taking a set of principles, a set of ideas, and communicating those ideas to the computer. What kind of ideas are you communicating? Here's information, and here's what you can do with that information. So all coding comes down to is representing that information programmatically or with code, and then writing code that actually does things to that information. Bam, you got it. So then you might ask yourself, okay, how do we represent some information to a computer? Well, you write code that involves variables and objects. When you're actually doing things to that information, that's when you're going to start getting into functions, but we'll talk about functions later. For now, you just need to think, okay, what information does the computer need to know or keep track of? Okay, well, if you've got some piece of information, it needs to remember or think about a dog. Well, you're going to be starting or initializing a variable or an object in order to represent that information to the computer. Bam. Then, if you want to do something to your information, if you want to move it from one place to another, if you want to display it to the user, if you want to change it or manipulate it, or create new information from that initial information, you're going to need to use functions to manipulate that information. Again, we're going to get into that later. Today, we are going to do a deep dive on the underlying principles of variables, what they are, and to start, I want to look at visualizing variables because I really gained a lot of skill as a programmer, especially when I was a beginner, when I started to understand how I could conceptualize exactly what was happening when I was declaring variables. So I want to go into this, and I've never seen anybody describe it this way, but it's, in my opinion, a great way to have it described. In order to visualize this information that we're communicating to the computer, the way I like to think about it is somewhere in your computer's memory, there's a little box, and this box has two key components, and there will be more that we'll add on in a second here, but fundamentally it's got a label. Let's say that's our variable name, and it's got some value. So that's gonna be in here. It's got some value. And let's just make it a little bit more concrete than some abstract value. Let's say our variable's value is 5, and instead of saying var name, let's just call it num, right, for number. So this is our freaking variable. There we go. Somewhere in the computer's memory, there's a little box with the label num containing the value 5. Now we've got the basic conception of our visual, but we're going to be building on this visual as we progress in complexity. Now let's look at variable declaration statements. So with the declaration statement, you're essentially creating one of those variables in memory. Now to declare a variable, you need to use a declaration statement. Now every programming languages or a lot of programming languages are going to do a few things different here. But fundamentally, each programming language has some format that you follow and certain keywords that you use in that format in order to communicate the nature of the variable you're trying to declare. So we'll start with this example using Swift. Swift is the primary language used for iOS app development. All right, here's our declaration statement format in Swift. First, you have your mutability keyword, which we'll discuss soon. Then you have the actual label, which we've already discussed, kind of. Then you have the type of the variable and the value. So let's write an actual line of code. Let's say we're going to use var. Let's call our variable number. Let's say the type is going to be int. And again, we'll talk about types in a second. We'll say equals, and we'll say that the value is 5. So when I look at this, I'm going to come in here, I'm going to say, okay, let's make a little box. Okay, this box is labeled number. This is exactly what we just did before. And it's got the value 5 inside. This equal sign is different from the equal sign that you're familiar with in math and science. It's not saying that this is the same as this, because that's what it means in math. If you say, 2 plus 3 equals 5, you're basically saying this is the same as this. What this actually means, what this equal sign means, is that we are assigning or putting this value into the box that this is the label for. So we're declaring this variable, it's some box, it's got this label number, and we're taking this value 5 and using the assignment operator, we're putting that value 5 into our box called number. Now, if we want to use our variable, there are two things we can do. We can get our value from our variable, or we can set our value from our variable. So in Swift, the syntax is just going to look like, number equals 2. And now essentially what's happened is using this assignment operator, we've taken our value, found our box using the label, and we've replaced the value in that box with this new number. This is called, with this new value. This is called setting. Now, getting essentially involves going in and grabbing the value inside of this box, taking the value from that box, and doing something with it. So let's say we wanted to create another variable. Let's say we created let number 2 equal number. So what's happening here? We created a little box. This one is labeled number 2 because we're initializing a new variable, and we're taking this value and we are assigning it to this variable. So that's getting and setting. Now we're ready to look at mutability. So this is where we're actually going to get into some more complex stuff, but it still should be pretty easy. So variables can essentially be changeable or not changeable. And that's all that mutability really refers to. So in Swift, you use this keyword, var, and keywords in programming languages are essentially just like vocab words or dictionary words that mean something to the computer, right? So var in the Swift programming language is a keyword that means this variable can be changed after declaration. So in this declaration statement, we're taking this value and assigning it to this variable. Since it's var, we can set it later. We can change it like we did before. The way I like to visualize this is imagine that you have an open box. It's a mutable variable, so you can take things out and put things back in. You can replace the value that's stored in that variable. So I've just updated our drawing a little bit real quick. Our format, mutability keyword, label, type, value. Down here we have our format, mutability keyword, which is var, which in Swift means that it's mutable. We've assigned this value 5, and since it's mutable, that means we can set and get it. Now, declaring an immutable variable simply means that you are declaring a variable that you cannot change further down the road. Now, you can get the value stored in mutable variables, but you can't set them. So we can visualize this like we were visualizing our variables earlier. We have our box, but now it's closed because you can't set it later and it still has its label. Now you might ask, why do we actually want to use immutability ever? Well, you could have some function that's going to output some value, and once it outputs that value, you're not going to want that value to be able to change throughout the rest of the runtime of your app. So you might ask, why do we use immutable variables? For starters, they are safer because if you have a value that you don't intend to change after that value's been set, then you don't risk accidentally changing it further down in your code. It's also more efficient. Efficient. Man, was that messy. I'm trying to cover up the fact that I don't think I know how to spell efficient. It's also more efficient because the processor isn't going to have to worry about reassigning new values further down the road. It only has to worry about grabbing those values. You might say, well, why not just use the value directly? Why don't I type in the value in my code itself? Well, there will be many situations where you won't know what that value is before your code is actually running, so your code needs to generate that value and assign that value and then keep that value. It's also sometimes the case that you might have a value that you're using multiple times throughout your app. Let's say you're storing a particular color and you're using that color all over the place. Instead of writing that color in your code all over the place, you can just assign that color to a variable, use that variable all over the place, and then if all of a sudden you want to change the color that you're using, you only have to change it in one place. So let's look at what we've talked about so far. Variable declaration statements, their formats, naming conventions, quick naming conventions, var name. This is called camel case because it looks like a camel, especially if you have of var. Kind of looks like a camel, ish. And then there is snake case, called snake because it's used in Python. It essentially involves separating words with underscores, whereas this involves separating words with capitals and keeping everything lowercase. We've talked about the assignment operator. We've talked about what it looks like to get and set variables. We've talked about mutability, what it means to be mutable, just meaning that you can set and get variables, versus immutable, which means you can get values from variables, but you can't set them. And we've talked about it's more efficient and why not just use the values directly. Now let's look at this last concept, types. So there are two types of types in programming languages. Essentially, a type is what is this type of variable? Very simple. There are two ways that types work. You can have static typing or dynamic typing, and then there's a feature that some programming languages have called type inference. But first we're going to look at the role of types. So there are many types of variables. We have integers, which are just numbers. We have strings, which are just a collection of characters, where characters are like A, B, C, 1, 2, 3, but these are not mathematical numbers. These are numbers as characters that you wouldn't be able to perform mathematical operations on. Bool is a true/false variable. You have floats / doubles, which are numbers with decimal points, 1, 2, 3. And floats and doubles only vary in how many decimal points they're actually able to contain. So floats max out at like 8 values, and the doubles max out at like 16 numbers. I might be wrong about those numbers, but it's not too important. You can also create your own types that are more complex, and we won't talk about this in too much detail because this is a very advanced topic, but you can create dogs. That could be another type of variable, which would have its own declaration format, so we're going to stick with these, which are called primitives. These are primitive types. They're kind of like the fundamental types available to you in most coding languages. Now, the way you might visualize a type is, so in this case, we are declaring this variable that's mutable, labeled number, and we're saying it's an integer, which is saying whatever is in this box is an integer. It's a number. It can follow the rules that numbers follow. So for example, if you have an int plus an int, you're going to get an int, which is a mathematical sum of, let's say it's 2 plus 5, you'll get 7, which is stored as an int. However, if you have string plus string and it's dog plus cat, you'll get dog cat. And notice there's no space put in there because you're literally just taking these two strings and sticking them together. Now here's what's important is if you have a string that is 2 plus a string that is 5, then you'll get 25. So that's what I meant about each type is going to have its own properties. Now in Swift, we have what's called static typing, and essentially what that means is you have this filter on your box in memory, and this filter has some type, and it's only going to allow values of that type to enter your box. So if you try to set your variable number with the value dog, since dog is not an integer, it won't go in. However, if I try to set it with even this to string, it won't go in because it's an integer. However, if I use another integer like we did before, okay, well then we can set it because 2 is an integer, so it's a value that can be used for the number variable. Now here we have this little line of code that assigns the value in number 2 to the value in number, and I've changed number 2 to be a string now. If you've been paying attention, you should know that this will not work. What this is doing is we're going in, we're getting the value stored in number 2, and we're taking that and we're trying to assign it to number, and that string doesn't go through. Now if we switch these, the order of these, and we say number 2 equals number, now we've got 2 problems. First off, this is an integer and would not pass number 2's filter. However, number 2 is also immutable, so you can't assign this value anyway. So that's what static typing is. Now dynamic typing is a form of typing that some programming languages use to allow you to bypass that whole system and just assign whatever values you want to whatever variables you want. I personally don't like this because it leads to less readable code. It's far more error prone in my opinion, but it's worth mentioning that dynamic typing is a little bit more dangerous, but it's super convenient because you can just assign whatever to whatever whenever you want in your code, and your program worries about it at what's called runtime. Now finally, we're going to look at inference. Inference is super simple. In this case where we say var number of type int is 5, type inference means we can just get rid of this and get rid of this, write our declaration statement like this, and it will infer, based on the value you put here, it will infer the type of number. And that's just done in its declaration statement, not in getting or setting statement. So in this case, this statement is going to look something like, okay, we make our number, we've got some filter, but we don't know what type we're filtering for, so we'll just take this value, and while we're declaring it, we put it in here, and oh, it's a number that went in there, so we'll call it an integer. Down here, it's the same thing. If we get rid of our type portion of our declaration statement, we're essentially saying like, okay, we're going to close this in just a second because it's an immutable variable, but we're taking this value, which is the string of 2, it could also be the string of dog, and we're going to put that into this box. And we could create a filter on this and say like, oh, it's a string, but we're not going to really be able to change it anyway. So hopefully that gives you an idea of what type inference is. It's essentially just your programming language being able to say, oh, this is the value that I'm putting in here. Let's infer what type it is based on the value itself. So at this point, I want to hop on over to Swift, and I want to show you what some of this stuff looks like. So let's run this code real quick to kind of see what's going on here. In this case, you can see we are accessing or getting the value of greeting, which is hello, and we're printing it to the screen. Down here, we're looking at what is the type of greeting. So in this case, we can see that we are using type inference. If I tell it, hey, this is a string, that will work as well, and you'll see that it'll print out and say, oh, that's a string. There we go. Now let's look at mutability. If I call this let, you'll see that our mutability statement still declares this variable with this value. Let's come down here and let's say, well, let's actually leave this as var and say let goodbye of type string equal greeting. Now if we run that both of these variables have that same value. Now if I say that this is goodbye, of course they aren't going to have that same value. It says goodbye. Now if we try to reassign goodbye to a new value, even though it's immutable, we will see you cannot assign to value goodbye is a let constant. Change let to var to make it mutable. Now if we call this an integer, the first thing that we'll see is that we have a problem. Cannot convert value of type string to specified type integer. As you can see right here, we have a value. We're trying to go through that filter and assign this string to a variable whose type is integer, and that's no good. So we've got to make that an integer. And it's going to be the same thing down here if we take greeting equal to, and remember this is mutable, so we can reassign values here, and we'll see it print out what we want it to print out. But if I try to assign it to goodbye, even though it's mutable, there's going to be a type mismatch. Cannot assign value of type string to type int. So the last thing I want to do is look at a couple of other programming languages and show how all of these concepts apply to all of the languages. The only difference is, are these types static or dynamic? What word am I going to use to say this variable is mutable or this variable is immutable? There are other situations like Python where certain types are immutable, which is kind of weird. But by understanding these underlying concepts, you can come to any language and quickly understand how to use it. And I'll show you how easy that translation happens right now. So I just had ChatGPT generate a comprehensive list of variable declaration statements. We come in here, okay, so this is Swift. So we've kind of looked at this last example, which is a little bit more complex and we don't need to go too deep into, but is essentially called an optional, which is saying here is a variable that's mutable of the integer type that is optional, which means if you think about that box, all that an optional is saying, int, this is saying it's an optional. All that optional is saying is there could be a value in here, or there could be no value in here. We can go and look in here and pull nothing out, or technically pull the value nil out, or we can go in here and pull a real value out. And that's useful, let's say if you're doing an app that has user authentication, and when the app opens up, you say that the user is not signed in, so you have a nil value or no value for the user. Then when you go and look inside of that box and you see, oh, the user box is empty, then we're going to prompt the user to log in. Whereas if the user is already logged in, when we open up that box, we'll see, oh, the user is already logged in. We don't need to present the login screen. Again, that gets a little bit more complicated, but it's useful to know. Now, if we have JavaScript, it's a little bit different, but it's actually very similar. So var means that it's mutable. Let also means that it's mutable. Const is just an immutable value, cannot be reassigned. So in JavaScript, you have all these are two of the same keywords that Swift uses, but they do not mean the same thing. Both declare mutable variables in JavaScript that are used in slightly different contexts. Const in JavaScript is analogous to let in Swift. So that's, annoying. You can also see in JavaScript, you're allowed to use dynamic typing, but they also allow for explicit typing. You'll also notice that the word that's used to define the type is different. In Swift, we use int and string, as I showed you earlier, but string is capitalized. Down here, you use number and string, but those are both lowercase. Small differences. Then we come down to Python. Python uses dynamic typing and determines its mutability based on the type of variable. So right here we have dynamic typing. It's mutable. We're saying x is some mutable integer of the value 7. Down here we have what's called type hinting, because Python allows for dynamic typing throughout the entire runtime of your application. So you can essentially assign any value to that variable regardless of its type at any time. If we're looking at C++, you don't have any type inference. I guess you do down here, but that's actually C++. So I guess if you're looking at C, you have no type inference. And you essentially have your mutability statement right here. No mutability statement means that it's mutable. Adding const means that it's immutable, and then you declare your variables in this format, which is type, label, assignment operator, value. And you gotta have your semicolon, because C++ sucks. Similar thing with Java, C#, Colton, they've all got their different specific approaches and formats as to how you do this. Now, if we do come back up to Rust, you'll notice that it says immutable constant. That might confuse you. Say, okay, what's the difference between immutable and constant? An immutable variable always has the same value, so isn't it constant throughout your app? Howdy folks, Future Dante here to say that the difference between constants and immutable variables is that constants have to be determined at compile time, whereas immutable variables can be determined during runtime. Now, Past Dante is going to explain the difference between compile time and runtime. When a program is executed, it goes through different phases: compilation, the language is compiled, and execution, runtime. The difference between compile time and runtime affects when the variables get initialized and whether they can be computed dynamically. So essentially what that's referring to, and this is getting pretty deep into comp-sci, but is you have all your code and that gets compiled into machine code, which is a bunch of ones and zeros, right? And then your processor goes through line by line, looking at each instruction represented as ones and zeros and executes that instruction. This process is called runtime. So the difference between constants and immutable variables is that an immutable variable's value can be set during runtime, whereas a constant's value must be set at compile time or before compile time. So if we're looking at C++, we could say an immutable variable can be set dynamically. Let's say we have some function that returns the value 2 plus 7, right? So this is going to return the value 9. This code will be executed during runtime, which means we can set this value to be the result of our function, right? And that's going to end up being the value 9. Now, with our compile time constant, this value has to be set before it's even going through and executing code. So if I try to set the value of function to this variable, we're going to have a problem. It needs to have already been determined before the program compiles. I hope that makes sense. I realize that's a little bit more on the complicated side and very deep computer science, computer engineering side of things, but it's good stuff to know. Another quick thing that I got ChatGPT to do earlier was output basically a list of declaration statement formats for different languages. So for Swift, we looked at this. You have your mutability term, your variable name, your type, your value. For JavaScript, you have your mutability term, your variable name, and your value. And it shows you, okay, your mutability term is let, your immutable term is constant. Down here we have Python. It's literally just variable name, value, which is essentially what we did at the very beginning of this video. And it shows something that's mutable, something that's immutable, and has this little note essentially describing how Python mutability is determined by the variable's type and is kind of outside of your control. Anyway, thank you for watching. I hope that was helpful. I am very curious about whether or not this format and this structure is actually helpful to people. There are tons of introductory videos on coding and how all this stuff works on the internet, but I find these visualizations and a deep understanding of the underlying concepts and principles very helpful in being a much more capable programmer than most other programmers are in a time where we need to differentiate ourselves between who's going to get replaced with AI and who's going to be kept on as a lead developer. So if you enjoyed that, subscribe, leave a comment, especially if you have any questions. And don't be a little bitch. Get your shit done, learn some things, produce some stuff, and pretty soon you'll be a very successful programmer making hella money. Adios, folks.